Now I'm going to talk about a couple different functional groups that are really important to the molecules that make up foods. And one of those functional groups is a carbonyl compound. So carbonyl means that we have a carbon attached to an oxygen with a double bond in between. And so that is what makes up a carbonyl. We can have other things attached on either side of that carbon, but if we have the carbon and the oxygen with the double bond, that is our carbonyl. We have different functional groups that contain carbonyls. So one is called a carboxylic acid. And when we name carboxylic acids, you'll see the ic acid at the end, and they're quite common. We also have amides. So amides have the carbonyl, but instead of being attached to a carbon, we're now attached to an NH2 group. So nitrogen with two hydrogens. And that's what makes it an amide. When we name amides, the end of the word has the actual functional group in it, AMIDE, amide. So again, carbonyl, carbon double bonded to oxygen, with the NH2 group makes the amide. Determine the formula from the line angle structures below. Also see if there are any carboxylic acids or amides. Pause the video and we'll talk about it in just a second. Let's look at our first one on the left. If we count the number of carbons, we have 1, 2, 3, 4, 5, 6. So our formula would be C6. We look at the hydrogens, 1, 2, 3, 4, 5. 3 would have none because there's already 4 bonds. 6, 7, 8, 9, 10, 11, 12. And we do have 1 oxygen. Now this is not a carboxylic acid. It does contain a carbonyl. However, carboxylic acids have to be directly connected to an oxygen with a hydrogen attached, so this is not a carboxylic acid. Let's look at our next example. So we have 1, 2, 3, 4, 5 carbons. So the hydrogen, this bond is actually just attached to a hydrogen because we have to draw it to show the attachment of the hydrogen. Now if we count the hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's not one on the carbon because it's got 4 bonds, but we do have the one that is attached. So we have 10 hydrogen and 1 oxygen. Now again, this is not a carboxylic acid because our carbon is not attached to an OH. It is just attached to H. And so this actually makes it an aldehyde group as opposed to a carboxylic acid. We look at the next formula, or our next line angle structure. We have 1, 2, 3 carbons. We look at the hydrogen, 1, 2, 3, 4, 5. We have 6, 7. And an oxygen and a nitrogen. Because we have oxygen and nitrogen, when we write our formulas, we actually write them in alphabetical order. So the nitrogen would come first and then the oxygen. If we look, this actually is an amide. So our amide composed of our carbon that is attached to the oxygen with a double bond, and then to our NH2 group. So this would be an amide. Last example, let's count our carbons. 1, 2, 3, 4, 5, 6, 7. C7. Now let's count our hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's no non-carbon. 6, 12, 13, 14. And we have 2 oxygens. Now this is not a carboxylic acid because we have a carbon that comes after the oxygen. If it was a carboxylic acid, it would have to be directly attached to a hydrogen. It is not, as it's attached to another carbon. And so this is a functional group that we call an ester. So we've had examples of an ester, an amide, an aldehyde, and a ketone. We do have a couple other functional groups that are important that do not contain the carbonyl group. So amines are nitrogen with 2 hydrogens attached to carbon. Again, the difference here is there's no double bonded oxygen. So this is an amine instead of an amide. The only difference in the name is the N-E instead of the D-E. So you do have to be a little careful with that, amine versus amide. And we have alcohol groups. So alcohols are oxygen attached to hydrogen. When we name them, the ending of the name becomes OL. So ethanol, this is the alcohol when you drink alcoholic beverages. It's 2 carbons that are singly bonded attached to an OH group.